A football team is playing a match. You know W, the chance they win, D, the chance they draw, and L, the chance they lose. There's a twist. Draws are not allowed, and if they happen, a rematch will be conducted, and this process can repeat. Given this information, show that the probability of the team winning is W divided by W plus L. Alright, so first let's build a little intuition about the problem, and then we'll go about proving this statement. Okay, so when the team plays a match, there are only three outcomes that could happen. They could either win the game, they could draw, or they could lose, right? And there's a chance of each of these three happening. Now, if they win or if they lose, well, that's the end of the match. If they draw, however, a rematch has to take place. So again, during the rematch, they can either win, draw, or lose, right? And you can imagine this process repeats basically forever, right? So there's kind of a zero chance basically of an infinite amount of draws, but yeah, it is possible to get like 100 draws and then a win. Okay, so the question is, what is the probability of winning the entire match? And any of these wins would be counted as a success. So any of these wins would add to our probability, right? And we want to show that the total probability of all of these wins is equal to W by W plus L. So just to give a clear-cut example, let's say the chance of winning was 20%, the chance of draw was 60%, and the chance of loss was also 20%. The formula would state that the chance of the team winning now with the no draws allowed rule is W plus L divided by, W divided by W plus L, which would be 0.2 divided by 0.2 plus 0.2, which would be 0.2 by 0.4 and then 0.5, right? Which makes sense. So they're saying if these probabilities, if draws are not allowed, you would expect to win 50% of the time. So now our job is to prove that, right? And let's see how we go about doing that, right? So let's define big W as big W is the final probable chance of winning, the final chance of winning, okay? And let's try and calculate it, okay? So let's sort of iterate through all of these games and add on to W, right? So when the first game, let's make a table maybe. So this is the game number, and this is the chance of W, right? So when the first game is played, the chance of winning is small w. For example, in this scenario, after the first game is played, the chance of the team winning the whole match is 0.2, right? Now, when the second game is played, the chance becomes d times w. So what this means is, if the second game is played, that means the first match was a draw. So in this tree, for example, if the second game is played, we go down a draw and then a win, right? And the chance of getting a draw is just d, 0.6. And once we get there, the chance of winning is w, right? And this is a pattern. So on the third game, the chance of winning is d squared times w. Fourth game, it's d cubed times w. So this is the important part. So you should understand this part. And we can basically prove this goes on forever, right? The chance of big W, so the chance of winning, is equal to W plus D times W plus D squared times W, and so on. And all this really signifies is that this is a normal win, this is a win after a draw, this is a win after 2 draws, this is a win after 3 draws, right? This is what it means. So let's work with this. So let's work with what W means. Now the first thing we can do is take small w common. So we get 1 plus D squared plus d cubed, and so on. And what you might notice is that this is a geometric progression. And the good thing about this is d is actually bound by 1, because d is a probability, right? So d can't be greater than 1. And we basically know d has to be less than 1 because the question doesn't make sense otherwise. So what we can do is we can just replace this whole thing by the formula of a converging GP, right? And the total of that would be 1 by 1 minus d, right? So if you don't know this formula, this is just a geometric progression formula. which is kind of important to know. I think the real formula is something like A by 1 minus R, right? And here A is 1 and R is D. Okay, so essentially we can replace this entire piece of, this entire bracket with 1 by 1 minus D. So big W becomes W divided by or times 1 by 1 minus D, or W by 1 minus D. So by the way, if you didn't understand this step, just search up geometric progressions and convergence. You get that. And for the last step, you can substitute 1 minus D with W plus L. So what I mean by this is the chance of winning, losing, and drawing, if you add all of them up, they equal 1, right? Because you have to either win, lose, or draw. So the chance of winning plus losing is equal to the chance of 1 minus D, subtracted D on both sides. So look, over here, we replace 1 by minus D with W plus L. So W becomes W by W plus L. And there, we've proved it. We've proved that the new chance of winning is actually just equal to the old chance of winning divided by W plus the old chance of losing.